All right, back at it. 2.6b, second half of section 2.6, still going to be proving angle relationships. The then and now, still the same as last section. Vocab, nothing new here. We've been through all of that many times, actually. All right. The properties of angle congruence, reflexive, symmetric, and transitive. Reflexive obviously says all angles are equal to themselves. Symmetric, again, that's to switch it. Doesn't matter what side is which. If they're congruent, they're congruent. Doesn't matter which one comes first, which one comes second. And transitive property, remember, matches very nicely to the law of syllogism. Just getting highlighting in here. Angle 1 and 2, angle 1 is red, angle 2 is blue. We start again, angle 2, so it stays blue. Angle 3 is different. So if that is true, then if I get the right colors, angle 1 and angle 3 are congruent. Syllogism, transitive property, substitution. Since 2 and 3 are the same, we could take 3 and stick it right there. And substitution works as well. They are all pretty much the same thing. Not all the time, but most of the time. Okay, congruent supplements theorem. Angle supplementary to the same angle or two congruent angles are congruent. That's the one I was digging for. If you catch the end of the last section of notes, this is the theorem that I wanted to have. I didn't have it yet, so I couldn't use it. If two angles are supplementary to the same angle or congruent angles, they are congruent. Congruent complements. Angles complementary to the same angle or congruent angles are congruent. Okay, so those are pretty important theorems. In the figure, angle 1 and angle 4 form a linear pair. And angle 3 plus angle 1 equal 180. Prove 3 and 4 are congruent. 3 and 4 are congruent. All right, given angle 1 and 4 form a linear pair. Angle 3 plus angle 1 equals 180. We're going to prove 3 and 4 are the same. I believe it's on the next page. So we don't have anything equal here. We're trying to get 3 and 4 to be the same, but we don't have that yet. These two together make a 180. Linear pairs are supplementary. 3 and 1 we already got is 180, so let's look at the proof here on the next page. Given stuff goes first. Angle 3 and angle 1 equal 180. Added together, 1 and 4 form a linear pair. Okay, so then it says 1 and 4 are supplementary. That was the last section. That is the supplements theorem. Because they're a linear pair means they are supplementary. Supplements theorem. Okay, definition of supplementary angles. Well, what is the definition of supplementary angles? Supplementary angles are two angles that add up to 180 degrees. Since 1 and 4 are supplementary, we can say angle 1 plus angle 4 equals 180 degrees. Now 3 and 4 are the same. All right, so this is where we have to look. We have to look at 3 and 1 equals 180 up top. 1 and 4 equals 180 down there at the bottom. Notice they both have angle 1. So this is the congruent supplements theorem. 3 and 4 are supplementary, each of them separately, supplementary with angle 1. So if that's true, then they have to be congruent to each other. Congruent supplements theorem. NTS theorem. Theorem. Congruent supplements theorem. All right, cool. In the figure, angle NYR, that's out here, NYR, through N, to Y, through R. RYA RYA is here, through R to Y through A. Form a linear pair. Well, that's good to know. Why is that good to know? Because linear pairs are supplementary. Supplements theorem. All right. AXY. Oh boy. I'm going to go highlighter this time. AXY. AXY. That's this angle here. AXY. And AXZ. Wait a minute. AXY and AXZ form a linear pair. AXZ. That's this one out here. AXZ. These two form a linear pair as well. That's handy to know because they are supplementary. And RYA. Maybe I'll highlight RYA. RYS, this one here. Okay, I'm just going to go up here and mark it so I remember what it was. And AXZ are congruent. AXZ are congruent. Prove NYR. So this is what we're going to prove. Get orange here. Prove NYR. NYR is down here. And AXY is in here. We'll prove those two are congruent. Well, looking at the picture, you'll notice in each of the angle pairs, the orange and the purple, I guess, highlighted angles are adjacent. Non-common side forms a line, which means they are a linear pair, which means they are supplementary. So if the purples are the same, the oranges have to be the same because of the congruent supplements theorem, because they are supplementary to congruent angles. So here we go. There's the proof. Given, of course, got the given stuff down. Two angles form a linear pair, then they are supplementary. Okay, notice, no, you don't have to. Notice they just wrote out the theorem. Two angles form a linear pair. I would have called this a supplements theorem. That's the title of it. They chose to actually write what the theorem says. Either way, I'm good with that. Okay, and again, this is a case where they separated the given stuff. And then down here, lastly, just like we said, it's like we said up here, the purples are the same. They're congruent as given. The oranges are both supplementary to the purples. So they are supplementary to congruent angles, so it makes them congruent. That should be and is the congruent supplements theorem. Congruent supplements theorem. And we could have written out two angles that are supplementary to congruent angles are congruent. That's the supplements theorem. Oh, there it is, right here. There it is in words. I used the title. Either way, whatever works for you. The only thing we don't use is the number. Theorem 2.8, I could care less about. That just says chapter 2, the 8th theorem that we've had. 8 theorems already. Wow. Vertical angles theorem. Now we have a theorem for vertical angles. We had a definition for vertical angles. I think we had maybe a postulate or something dealing with vertical angles. I don't remember anymore. But now we have a theorem, most powerful thing there is. Vertical angles are congruent. Prove that if angle 1 and angle 2 are vertical angles, okay, the vertical angles means they're congruent. And we have some information about each of them. Then we're going to prove that, well, they're both 37. All right, so angle 1 and angle 2 are verticals. That's all we have, vertical angles. The vertical angles theorem says vertical angles are congruent. Therefore, angle 1 is congruent to angle 2. If you're given information, use it. We're given vertical angles. That means they're congruent. The definition of congruent angles or definition of congruence, again, remember, going from congruent to equals, definition of congruent, whatever they are. We had congruent segments previously. Now we're talking about congruent angles. All right, now we're putting in the d minus 32 and the 175 minus 2d. When we take something out, put something in its place, that's substitution. Now, this is a case where syllogism and transitive wouldn't work for substitution. Okay, if you're starting with transitive, then you usually can use substitution or syllogism, but starting with substitution doesn't give you the other two. Okay, the addition property of equality. Okay, they added probably 32 to both sides, right? Probably where we would have started. All right, that's what they did. 3d minus 32. No, they didn't. They did the d. Okay, and now we're going to add the 32 to both sides. Once again, addition property. And then now we're going to have d equals 207 divide 3 is 69. 69 divide 3 divide 3. Okay, division property. D equals angle D. D equals not angle D. So then we're going to substitute in here. 69 minus 32 is 37. 175 minus 2 times 69. 175 minus, that's 12 and 18, 138. Not an equal, is a minus. Not an equal, is a minus. Boy, we put so many equal signs in math. Just get a habit. 175 minus 138 is 37. There we go. We did it. We proved it. Equals 37. A and Z are vertical. A and Z are vertical. What's that mean? It means angle A is congruent to angle Z. By the definition of congruent angles, the measure of angle A equals the measure of angle Z. Okay, we went from congruent to equals. Going from congruent to equals. Definition of congruent angles. All right, so we're just going to substitute in. A is 3B minus 23, and Z is 152 minus 4B. Okay, so I'm going to add 23. 3B. Moment of dyslexia there. 23 equals 175 minus 4B. Going to add a 4B. Add a 4B. Gets us 7 of them B's. 175 divided by 7. B is 175 divide 7 is 25. 25. That's B, though. That's not the angle. So angle A, putting that right in there. Angle A equals 3 times 25 minus 23. 3 times 25 is 75. 3 quarters makes 75 cents. 7, 6, 5, 52. Got a 52. Oh, darn them. Now we got to figure out which one is Z. Angle Z is 152 minus 4 times 25. 4 quarters is a buck. 152 equals 100 pennies. Not equals, minus there. Sheesh. Sorry, let me fix this right there. I don't have 2 equal signs, goofball. 152 minus 100 is 52. Boom. Boom, be boom, boom. 52, 52, 52, 52. B, yay. Right angles theorems. Perpendicular lines intersect to form 4 right angles. All right angles are congruent, of course. Perpendicular lines form congruent adjacent angles. These are all back. We had these back before when we had definition of perpendicular lines, and now they're in a theorem. If 2 angles are congruent and supplementary, then each angle is a right angle. So if they're both the same and they add up to 180, the only numbers that do that are 90 and 90. That can be the same and add up to 180. If 2 congruent angles form a linear pair, then they are right angles. So if they're congruent and a linear pair, they are right angles. Copy and complete the proof. No, we're just going to fill in the blanks. I'm not going to go look at anything because I know what goes in A. A is given. Don't need to look any further than that. All right. Angle 1 and angle 3 are complementary. Angle 2 and angle 3 are complementary. It just froze up again here. Hope it, okay, doesn't last too long. Good, good, good. All right, then it goes down here to that they add up to 90 degrees. What tells us that? Well, that's what complementary angles do. So if that's what complementary angles do, which is add up to 90 degrees, that's the definition of complementary angles. Complementary angles. Okay, letter C. Angle 1 and 3. All right, so all they did here was they took this right here and they put it right here. All right, this is one of the cases where transitive, substitution, syllogism all work. I'm more of a substitution person. Take something out, put something in its place. Reflexive property. Wow, reflexive property. Reflexive property. Everything equals itself. Okay, so what we haven't said here yet is that angle 3 and angle 3 actually equal themselves. They're equal each other. Angle 3 is congruent to angle 3. And what that allows us to do is subtract the angle 3's from both sides up here, leaving us 1 and 2 are equal. All right, so we're going to go, that's subtraction. Subtraction property. Okay, and then notice here we're going from equal to congruent. Equal to congruent is the definition of congruent angles. Angles that are equal in measure are called congruent. Angles that are called congruent are equal in measure. Definition of congruent angles. Right, two-column proof. We can do that. Statements, reasons. Okay, draw a line down. We're going to draw a line over. We're going to put a number 1. We're going to write in. I'm not looking at anything other than what is given. I want my free, easy points. There it is. Everybody should do that. All right, 4 and 7 are the same. All right, what do we know here? 4 and 7 are congruent. 4 and 7 are congruent. Notice, get me a new color here. I love that red right there. 4 and 5 are verticals. 6 and 7 are verticals. 2. Angle 4 and angle 5 are vertical angles. Angle 6 and angle 7 are vertical angles. Vertical angles. 2, that is the definition of vertical angles. Okay, so hopefully as you're going through, you're going to notice the importance of vocabulary. You know, the definition of vertical angles back in sheets probably 1A, could have been 1B chapter, not sure, are 2 angles formed by intersecting lines. So that was the definition of vertical angles that we knew and loved then and get still the same. Okay, so if they are vertical, they are congruent. Angle 4, congruent angle 5. Angle 6, congruent angle 7. Okay, so if they're vertical, they're congruent. That's the vertical angles theorem. Vertical angles theorem from earlier in this section. All right, so we have 4 and 5. So we're trying, where are we going? We're going to 5 and 6. Okay, now it's time to think about, we're going to from 5 to 6. All right, we know 4 and 7 are the same. Okay, so let's get an orange here. Okay, we know 4 and 7 are the same. 4 and 7 are the same. So what about 5 and 6? Well, what if, since 4 is congruent to 5, I need to get 5 and 6. What if I take 5 and put here? Can I do that? Since 4 and 7 are the same? Well, sure I can. I got the circles in orange. That's syllogism. That's transitive. That's substitution. Any of the above. So angle 5, or 6, sorry. Back. Angle 6, I'm just copying the line up above. It's congruent to angle 5. That's where we're going, isn't it? 6 and 5? Absolutely. 4. And that is, I'll use substitution. Transitive property works, as well as syllogism. And done. I'm not going to make you switch those around. We could use symmetric property and switch those the way they have them up there, but it doesn't matter. We already know that. All right, so good luck. Keep working hard. Things are going well. Keep it going, and I'll see you soon. Have a good one.